to summarize the basics of the QE because we are going to the advanced stage of discussion, analytical discussions, purely mathematical description presented, and therefore once more I would like to just revisit once more the previous concepts, and whosoever has not got the concept clear, has not made some, because of some reasons the concept is clear, they will get it again. So Ewing theory is nothing else but a branch of the operation research. We have to begin with these words because this is a part and integral of the operation research. So now one thing is also very important, that who discovered, if I use the text here, who discovered the concept of Ewing theory, and in which year this concept was discovered, then I would like to let you know this very point, that it was the year 1909. The Danish engineer named engineer A.K. Erlong. Engineer A.K. Erlong discovered the concept of Ewing theory. Basically, he was an engineer and he was discussing some problems of the telecommunication, means telephone. So during the discussion of the telecommunication problem, he wrote a research paper, and that research paper was means all means all. Okay. So I was telling you this very point, that now it's okay. This was year this was the year this was the year year 9. Year 909. Oh, sorry, 1919909. I told you this was engineer A.K. Erlang. A.K. Erlang. He was Danish. He was discussing a telecommunication problem. Telecommunication problem means a problem related to telephone. Then he was writing a paper, and that he was writing a research paper entitled as probabilities, theory of probability, theory of probabilities, and study of and study of telephonic problem. So this was the year of, you can see, year of revolution in the field of telecommunication. This was year of revolution in the area of telecommunication. And ultimately he was successful in publishing this very research paper, theory of probabilities and the study of telecommunication. And in this way, after discovery of giving theory, he developed the giving theory, and therefore he became, I would like to tell you this point, this is very important, the father of, so year 1909, engineer A.K. Lang, the area of research where it was applied, the area of telecommunication problem, and the mathematical study or statistical study was what? The theory of probabilities and telephonic problem. So probability theory he was discussing during the telecommunication problem, meaning thereby this concept became very powerful. And nowadays what is happening, telecommunication is not one area. Nowadays how many area of application, computer, okay? Every area, commerce, the business, the economics, engineering, etc. So nowadays we can say no any area is left, no any area is untouched. The theory of game theory is not capable. So now this has become very, very important concept. Now I would like to share one more very important point, which oftenly we face and encounter this confusion. I am that very confusion is what? That very confusion is what? This is what is the basic difference? Difference. uh, Basic difference between, I would like to share one more very important point, because we are just slowly and slowly we are advancing towards the rigorous concept of the queuing theory, rigorous mathematical and analytical discussion of the queuing theory, and therefore this point up to this stage must be clear. What is the queuing theory? What is the queuing theory? What is the queuing system? Model. Please mute. Mute. Deepak,
आनंद करिए
mute. You tell him.
आनंद म्यूट कर लो स्पीकर.
What is the basic difference between these 3 points? The queuing theory, the queuing system, and queuing model. If somebody is asking you, particularly if you are saying yes, queuing theory is prescribed in our course. Somebody may say, you know the queuing system. You will say, yes, sir, I know the queuing model. In Viva Bosi, in your presentation, in your research presentation, this is very small question, but difficult to answer. That what is queuing theory, what is queuing system, and queuing model. People are developing the models, working on various models. You will find the general queuing models, the specialized queuing models like MM1, you will find MM2, you will find MMS, and then you will find MG1, you will find GG1, you will find MD1. So there are number of queuing models, and people also say these are the queuing systems, and everything is contained in the queuing theory. So today it must be clear that what is the how we can basically or primarily distinguish between these points. So what is the queuing theory? The queuing theory, this is the broader, or you can say the broadest area of discussion, here, the broadest area of discussion, broadest area of discussion. Broadest area of discussion means involving what? Theory. He has again unmuted. You telephone him, Deepak.
Yes,
Yes,
sir.
you telephone him. He has again made this thing. Archana has also unmuted. I don't know why she has unmuted. Akash, Anamika, Anand Verma, Anand Verma has unmuted.
Yes, sir. बंद हो गया.
Okay, so what is the main difference I was discussing? Queuing theory. How the queuing theory is? What are the things which involves or encompasses queuing theory? So it's a theory and principles. All principles. 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 And then methods. Methods and techniques. Methods and techniques. All techniques. Then it's a derivation. It's a derivation. It's a sub-derivation. It's sub-derivation. It's analytical discussion. Discussions. Discussions. And what is remaining more? Every theory, every analytical discussion, and then its application. Applications in various tools, in various fields. So you can say discussions, you can also add here numerical examples or numerical demonstrations. Numerical demonstrations. So this all means we can say all possible discussion. All possible discussions. Theory, in very short, theory, derivation, and application. This is all about the queuing theory. Now, but here, here, all possible discussions means what? All possible discussions. These discussions may be economical, maybe sociological, the effect of the giving, problems related to psychological, the related to computer, related to this telecommunication, the architecture, etc. And main is the mathematical. I am just my own area. So there may be different and vast discussion. This discussion is a vast discussion. Vast discussion. So this is why the queuing theory. Now, what is the queuing system? Queuing system. Somebody says queuing system. Somebody says in the research papers also you will find, in the books also find. Somebody says queuing model. Somebody says queuing systems. But during the presentation, if you ask what is the difference between the queuing theory, queuing system, queuing model, MM1 is the queuing model or the queuing system, then it is very difficult to answer. So now we talk about the queuing system. Queuing system. What is the queuing system? Queuing system is a workable, you can say, this is a workable. This refers to a workable description of workable description of queuing. You look at workable description here. The workable description is very important. Workable description is important because queuing theory is very vast. Queuing theory is very vast because this is already a vast. So if it is a vast discussion, then talk about, then how do we talk about, how we can talk about, how can we talk about this whole queuing thing? Therefore, it is made a working description. How, what kind of things this will involve? What kind of this will involve? This will involve, this will encompass. Encompass means include. This will encompass all possible workable components of queues. So all possible components means what? They include popular thing. What? The number one is what? Arrival process. I have come to your test now. Arrival process. Second, this process. Process. Next is capacity of the system. Capacity of the system. Capacity of the system. Next, discipline of the system. Discipline of the system, and last is the behavior of So these are the important components. The arrival, this is also known as a arrival mechanism. Arrival, sometimes in some literature you will find the arrival pattern, arrival mechanism. So service process means service mechanism, capacity of the system, on the nature of the source, and discipline of the system and behavior of it. Okay, so
Yes.
this very thing is known as the queuing system. Now let us come to the queuing model. So what is queuing model? Queuing model. What is queuing model? This queuing model is a mathematical transformation or it's a mathematical transformation or mathematical programming of queuing system. You look at here. This part is very important. This mathematical transformation or mathematical programming, of queuing system. How this will be mathematically programmed? This will be mathematically programmed using what we use? Variables. When variables will be used? When we have deterministic arrival or deterministic service. Otherwise, what we will use? Otherwise, what will be used? Random variable. And then what we use, if there are random variables, then there will be a probability distributions. Probability distributions. And what also used is further the mathematical expectations. Everywhere in mathematical expectations. And further, what we use, the first four application of moments, sometimes without variance. We will there is a formula for the variance. How much fluctuation takes place in the giving or waiting line? So that will be variance. Variance is the second moment of the distribution.
Yes,
If required, I'm not saying that everywhere this will be required. So if required. So this is the when we talk about the giving model, then basically this is a mathematical one. In one line, that is a mathematical which is used to study the what? Giving system. Unless we transform this giving system into a mathematical model, we cannot study the giving system. And therefore, if you remember, as a mathematical definition, we have discussed and started with the definition of the giving theory. What was the definition of the giving theory? Giving theory is a mathematical study of waiting line. If you remember, what is giving theory? Giving theory is a mathematical study of waiting line or queue. Waiting line. So these are three important points which we need to differentiate, because everywhere we feel confusion, we feel doubts about the giving system, giving model, and the giving theory. So, as a comparison, if we write the Q here, QT, as a concept, QT means giving theory, then it is an giving system. Is broader than giving system, and the giving system is broader than giving model. Broader than giving model. Okay. So I hope this doubt that what is the difference between including clean system and clean. This is now clear. Is it okay?
Yes, sir.
Okay. So again, I come to this very point, since this is a mathematical discussion, I come to our text. One more important discussion we used, we applied here, very important. The application, I'm just revising because while dealing with the mathematics, we should not have any confusion. We must have the utmost clarity of the subject of the issue, application of exponential distribution. Every time this is very important. Exponential distribution. So why we use the exponential distribution for inter-arrival? For what application we apply? We apply for application of we apply for the inter-arrival times and for inter service times. And popularly we know all these types of arrival times, arrival times, service time, arrival times and service time. Okay. So if you remember the arrival process, what is the main properties of the arrival process? A main property of the arrival process is that
Continue.
number of arrivals of the customers follows the Poisson distribution. And arrival is random. Arrival is quite random, not completely, totally random. It is found in the literature, totally random or completely. The first point. Second point is what? The inter-arrivals or inter-arrivals are independent. Inter-arrivals are independent. Third point is the elapsed time of arrivals is not considered for discussing the present or current, whatever it is, or current Correct. Correct. So arrival is totally random. Arrival is totally random means you must be very clear. Means number of arrivals as well as well as inter arrival times. I mean to say both. Either we talk about the number of arrivals or as well as inter arrival times. Both are completely random. And inter-arrivals are
Independent.
and third point is last time, past time, if you remember, past time we have discussed it mathematically also. It is not considered that discussing the present arrival, meaning hereby this property is known as lack of lack of memory. Lack of memory.
Ignoring. Yes, sir. Forgetfulness property.
Yes, forgetfulness.
Fullness property.
Forgetfulness property. Forgetfulness property. I am going to answer to the question that why we apply the exponential distribution for inter-arrival time, or we are applying the Poisson distribution for number of arrivals. Both have the same answer. Either we discuss it in terms of inter-arrivals or we discuss it in terms of number of customers. Number of customers or number of arrival of the customer is a discrete variable.
Yes,
Number is always discrete. Means one arrival, two arrival, three arrival, four arrival, like this so on. And thanks to infinity. 1 lakh arrival, 1,000 arrival, whatever it is. This is a discrete random variable. Therefore, we say that we will apply here the Poisson distribution.
yes, sir.
When we talk about the inter-arrival time, we say that this is we are as the application of exponential distribution. The reason why, because in the derivation or in the construction of the concept of exponential distributions, these three these three
Yes, sir.
means
Error.
are as a assumption. As assumptions. If you just study your exponential distributions, you will find that because of elapsed time of arrivals or arrival times, arrival of customers, this follows the forgetfulness. Which one? The exponential. This is the assumption. And we have also proved it. Arrival is totally random. You cannot say that. This is very important. Or inter-arrival times are totally, second one. This is first. Arrival is totally random. You cannot say it is partially random. No, not at all. The arrival of the customers will be completely and totally random. You cannot say this is a partially random. Otherwise, the exponential won't apply here. Similarly, the inter-arrivals were independent. Inter-arrivals are independent. Means inter-arrival times are also independent. Inter-arrival of the customers is also independent. Independent means any customer cannot say that if I reach, then and only then the second customer will reach from the doctor's clinic or on any service station of the queue. If it happens, then exponential won't apply. So sometimes there may be clash, there may be, contradiction in between the reality and this exponential application of exponential distribution, this theory. But sometimes this also happens that I and you will go both to the doctor's clinic because I have also problem, you have also problem suddenly. So you are interdependent and reaching there. So this is the weakness of the transformation of the mathematics into mathematics of the reality. So sometimes reality and application of the exponential distribution may not match. The reason I told you. But these are the assumptions which we must follow. Otherwise, the application of the exponential distributions as well as the application of the Poisson distributions won't be applied here. Okay, so I think these are the basic points which we discussed. Now I will continue. Today is enough, I think. And if you have any doubts or questions, then now you can, I can unmute to have some questions if somebody wants to ask. Right, everyone, and now they can unmute all now. Unmute all. Mute all. Now people are unmuted, but
Yes,
here
sir.
somebody is not unmuted. So you will have any discussion or let us close?
Sir,
Deepak.
ये सर जैसे एक्सपोनेंशियल डिस्ट्रीब्यूशन जो है उसमें सर जैसे कॉन्टिन्यूअस होता है वेरिएबल, तो सर उसमें जैसे टाइम की बात करते हैं, नंबर ऑफ सक्सेसिव जो हमारे अराइवल्स होते हैं उनके बीच जो टाइम होता है वो कॉन्टिन्यूअस होना चाहिए ना?
हाँ वही द सेम, हाँ इंटर
यस
अराइवल।
यस, और जैसे पॉइसन में हम जब बात करते हैं
ऐसे
तो वहाँ पे
10-15 पर कोई आया
यस
और
सर,
कोई 10-20 पर आया,
यस सर,
तो ये जो टाइम हुआ 5 मिनट का,
यस सर,
क्या हो गया T2 माइनस T1।
यस
अगर
सर,
हम T1 से स्टार्ट करते हैं तो पहले में 5 मिनट आया, फिर कोई आ गया 10-11 बजे आया, वो T3 हो गया। तो कितने का डिफरेंस हो गया? यहाँ तो 5 का डिफरेंस था, अब बहुत डिफरेंस बड़ा हो गया।
यस सर,
कितना हो गया? We can compute it. ऐसे T4 होगा, ऐसे T5 होगा, तो T5 minus T4, T5 minus T4, this is like intervals, means if T1, you ask a good question, T1, this is T2, and this is T3, T3, so forth, so on, this is Tn, okay? So if this is in this way, then then what is happening here? We are computing, just you can say here, we are computing T2 minus T1, and then T3 minus T2, and so forth, so on. This will go, and this is Tn
minus Tn minus 1.
Yes, Tn minus 1. So this is not uniform. This time, these times are not uniform, because this may be 5 minutes, this may be 20 minutes, this may be again 1 minute, this be again an hour. So it is not in your control. This is quite random. So whatever time is this interval, first interval time, second interval time, the nth interval time, these times are, that is why we always say interarrival. These times are continuous. Now your question, क्या पूछना चाहते हो? अब शायद ज्यादा क्लियर होगा.
यस सर, तो सर जैसे हम कह रहे थे, जो मतलब इंटर अराइवल टाइम होता है वो जरूरी नहीं है कि सेम हो जाए सब लोगों का वहाँ पे. तो जो टाइम डिफरेंस आ रहा है यहाँ पे, जैसे एक्सपोनेंशियल की बात करें तो ये कंटिन्यूअस होता है.
हाँ.
तो सर जैसे अब टाइम यहाँ पे, जैसे हम बात करें कि सबकी टाइम अलग अलग आ रही है, जो अराइवल्स की मतलब टाइमिंग है वो अलग अलग है. तो सर एक्सपोनेंशियल लगाने का मतलब नहीं समझ में आ रहा था.
एक्सपोनेंशियल लगाने का मतलब ये समझ में आया. एक्सपोनेंशियल is a continuous random variable distribution. Continuous distribution. Okay. इसमें फॉर एग्जाम्पल आप 10:15 पर पहला कस्टमर आया. दूसरा कस्टमर आया 10:20 पर आया. सपोज तीसरा 10:03 बाद आ गया.
23.
Okay. So
yes,
this time is basically what is happening. Zero time. We started at zero time, and we are continuing up to that time till this server is giving the service. Till server giving the service, time is not broken anywhere. कब तक चलेगा? For example, 2 p.m.
yes sir.
Zero time means 2 p.m. means 10:15 to 2 p.m.
yes sir.
So all the inter-arrival times, if they are summed up, you can sum up.
Yes,
this plus this, then this is all is continuous total time. Okay. So for example, the first day, you have seen one example. Second day, third day, point of times are different. T1, 1 arrival. T2, 2 arrival. T3, 3 arrival. So when we talk about the arrival, then Poisson. When you can say T2 minus T1, what will follow, sir? What distribution this will follow? Then we will say T2 minus T1 is a time variable. This will follow the exponential. But if you say, sir, in between T1 and T2, how many customers have come, what they will follow, so that number will follow the Poisson distribution. Because Poisson is the discrete and this is the continuous. But T1 and T2, they all points of time, but they are random. They are random. And therefore, the nature of the inter-arrival times become also random. You can't say that difference is only 5 minutes, difference is only 30 minutes, difference is only an hour. कुछ भी हो सकता है, रैंडम होगा। लेकिन आप 2 घंटे तक वेट करते रहे, कोई नहीं है, डॉक्टर खाली है और इकट्ठे कई लोग आ गए। सो दिस इज रैंडम, इसलिए इसको एक्सपोनेंशियल कहा गया और इस तीनों प्रॉपर्टी की वजह से कहा गया और इनका को बेसिकली यूज है। नाउ वी आर गोइंग टू यूज दिस इन प्योर बर्थ मॉडल एंड प्योर डेथ मॉडल। डेरिवेशन देखा है, कल मैं इसको रिवाइज करके फिर आगे बढ़ूंगा। ओके, थैंक यू। आपका अपना लेक्चर हो